Time travel has long captivated the human imagination, weaving its way through the fabric of literature, film, and philosophical debate. From H.G. Wells's The Time Machine to movies like Back to the Future and Interstellar, the idea of traversing the boundaries of time has sparked endless curiosity and speculation. But is time travel merely a fanciful concept, or does science provide a pathway to its possibility? To explore this question, it is essential to delve into the realms of physics, particularly the theories of relativity and quantum mechanics, as well as the implications of time travel on causality and the universe itself. At the heart of the discussion on time travel lies Albert Einstein's theory of relativity. Introduced in the early 20th century, this groundbreaking theory fundamentally altered our understanding of time and space. Einstein proposed that time is not a fixed entity, but rather a dimension intertwined with the three dimensions of space, forming what is known as space-time. According to relativity, the flow of time can be affected by speed and gravity. The closer one travels to the speed of light, the slower time passes for that traveler compared to someone at rest. This phenomenon, known as time dilation, has been experimentally verified through various means, including observations of particles moving at high speeds and precise measurements using atomic clocks on fast-moving jets. The implications of time dilation suggest that, in theory, a form of time travel is possible. If a person could travel at a significant fraction of the speed of light, they could experience time at a slower rate than those remaining stationary on Earth. For example, if an astronaut were to embark on a journey through space at near light speed for what feels like only a few years to them, they could return to find that decades or even centuries have passed on Earth. This scenario, while theoretically plausible, raises profound questions about the nature of time and the human experience. Would the astronaut be able to communicate with those who have aged but significantly in their absence? Would they feel a sense of loss for the time that has passed? Or would they embrace their unique experience? Yet, while this form of time travel into the future seems within the realm of scientific possibility, traveling back in time presents a far more complex challenge. The concept of backward time travel introduces paradoxes that have perplexed physicists and philosophers alike. The most famous of these is the grandfather paradox. What would happen if a time traveler were to go back in time and inadvertently prevent their grandfather from meeting their grandmother? If that were to occur, the time traveler would never be born, leading to an apparent contradiction. Such paradoxes raise fundamental questions about causality and the linear progression of time. One proposed resolution to the grandfather paradox is the idea of parallel universes or alternate timelines. In this view, when a time traveler makes a change in the past, they do not alter their original timeline, but instead create a new branch of reality. This concept aligns with interpretations of quantum mechanics, particularly the many worlds interpretation, which posits that all possible outcomes of quantum events exist in parallel universes. While this theory offers a fascinating solution to the paradox, it also leads to a multitude of new questions. How would one navigate between these timelines? Would the traveler retain memories from their original timeline? Another intriguing idea related to time travel is the concept of closed time-like curves, which are solutions to the equations of general relativity that allow for paths through spacetime that loop back on themselves. Theoretical constructs such as wormholes or rotating black holes, known as Kerr black holes, could potentially enable such curves. A wormhole, for instance, could act as a shortcut between 2 points in spacetime, theoretically allowing for instantaneous travel between them. However, the stability of wormholes remains a significant hurdle. They would require exotic matter with negative energy density to keep them open, a substance that has yet to be discovered or created. The exploration of time travel also intersects with the realm of quantum mechanics, which governs the behavior of particles at the smallest scales. Quantum entanglement, where particles become interconnected in such a way that the state of one instantaneously affects the state of another, regardless of distance, raises questions about the nature of time itself. Some theorists propose that if we could manipulate quantum entanglement, we might unlock new avenues for time travel or even communication across time. However, these ideas remain speculative and unproven. The philosophical implications of time travel extend beyond the scientific realm, prompting questions about free will, determinism, and the nature of reality. If time travel were possible, would it undermine our understanding of cause and effect? Would the ability to alter past events lead to a deterministic universe where every action is preordained? Or would it introduce a chaotic element where every choice creates divergent timelines? Such inquiries delve into the very foundations of human existence, challenging our perceptions of agency and consequence. Moreover, the ethical considerations of time travel are profound. If one could travel back in time, what responsibilities would come with that power? Would it be ethical to intervene in historical events, knowing that even small changes could have significant ripple effects? The potential to alter the course of history raises moral dilemmas that would require careful consideration. Would we seek to prevent tragedies or injustices, or would we risk creating unforeseen consequences that could lead to greater suffering? The exploration of time travel also invites speculation about its practical applications. If time travel were feasible, it could revolutionize our understanding of history, allowing us to witness pivotal moments firsthand or to gather knowledge lost to time. Imagine the potential for scientific advancement if we could consult with historical figures or observe the natural world in its primordial state. However, the potential for misuse is equally concerning. The temptation to exploit time travel for personal gain or to alter significant events could lead to catastrophic outcomes. Despite the tantalizing possibilities, the scientific consensus remains that time travel, particularly into the past, faces insurmountable challenges. Current understanding of physics does not provide a practical method for achieving backward time travel, and many physicists remain skeptical about its feasibility. The laws of thermodynamics, particularly the second law, which states that entropy in a closed system tends to increase over time, further complicate the notion of reversing time. The idea of a universe where time can flow backward seems to contradict our observations of natural processes. Yet, the pursuit of understanding time and its intricacies continues to inspire scientists and thinkers. Research in theoretical physics, cosmology, and quantum mechanics pushes the boundaries of our knowledge, revealing new insights into the nature of reality. Each discovery brings us closer to unraveling the mysteries of time, even if it does not lead to practical time travel. In popular culture, time travel remains a rich source of storytelling, allowing creators to explore themes of nostalgia, regret, and the consequences of our actions. The allure of visiting the past or glimpsing the future resonates deeply with the human experience, reflecting our desire to understand our place in the universe. Through narratives of time travel, we confront our fears and aspirations, grappling with the complexities of existence and the passage of time. As we navigate the intricacies of time, it becomes clear that while time travel may remain a theoretical construct for now, the exploration of its possibilities serves as a profound reminder of our quest for knowledge and understanding. The questions it raises about the nature of reality, causality, and the human experience continue to inspire curiosity and wonder. Whether time travel is ultimately deemed scientifically possible or remains a tantalizing dream, its exploration invites us to reflect on the nature of time itself and our relationship with it. In conclusion, time travel occupies a unique space at the intersection of science, philosophy, and imagination. While the scientific community grapples with the complexities and paradoxes associated with time travel, the exploration of its possibilities continues to inspire inquiry and creativity. Whether through the lens of theoretical physics or the narratives of popular culture, the concept of time travel resonates with our deepest desires to understand the universe and our place within it. As we continue to unravel the mysteries of time, we may find that the journey itself, rather than the destination, holds the key to our understanding of existence.